Sorry, I didn't mean to rant on you. Good morning, everybody. Miss Wilson's in a ranting mood today. I'm going to take attendance. And while I do that, I'll put your precious little quote of the day up, if that's at all possible. There we go. Jonathan's here. So let's see. Zachary's here. Jonathan's here. Sophia is here. Dia's here. Yana's here. Shri is here. Scotty Mathangi. You're on. Sashank is here. Now, aren't some of you supposed to be here taking a test? No or yes, or I don't know. It seems like I've seen a few names on the testing schedule for today. I might be wrong on that, but is anybody supposed to be at school taking a test today?
Like some people are, I think, but there has not been much communication about that to us. So
Yeah.
That's nice. All the communications going on in the school, let me tell you. So this is very interesting. Well, it's on their end, not yours, so I wouldn't worry about that too much. I mean, I don't know what else to say. But so be it. Did we finish 2.8 last time in here? Yes? Continuity? James, did we finish 2.8 in here?
I think so. That was our homework from last class.
Your what?
That was our homework from last class too.
Yeah, okay. So let me go over a few bell works and the objectives, and then we'll go over any homework questions you guys may have had. So prior AP questions, okay, these are no calculator questions. Can you answer the question? So read it carefully. It's a multiple choice non-calculator. Of course, calculator is not going to help you. And tell me what the correct answer would be. Let's see, I think Christopher has testing. He emailed me. James is here. She's here. Anybody have an answer yet?
Would it be A?
Would it be A? So Rishi thinks it's A, 1 relative maximum and 2 relative minimum. Anybody agree, disagree?
I agree with what he said.
You agree with what he said? So Sophia, and was it Rishi that answered it first?
Yeah.
So if we look at this graph from A to B, this is the graph of the derivative function, right? And we see our derivative goes from negative to positive at this point here. So that would be a relative what? Would it be a max or a min when the derivative goes from negative to positive?
Minimum.
A minimum, right? Because when the derivative is negative, that means that our function is decreasing. And when our derivative is positive, that means our function goes to increasing. So we've got the bottom of a bowl there. So we're thinking of a relative minimum. Antonio is here. So we've got a relative minimum here. At this 0, the derivative is going from positive to negative. So our function goes from increase to decrease. So that means we should have a relative maximum at that point. And then over here, our derivative goes from negative to positive again, indicating a relative minimum. So it looks like there's 2 relative minimum here, and 1 relative maximum here. Is everybody okay with that? Any questions? Okay, let's look at the next one. Which of the following must be true? Mull that over. Gabriel's absent and Gabriel's absent. Both of my Gabriel. Do 2 Gabriels make a Gabriel-I? Gabriel-I? Antonio is here. Scott, you have an answer yet?
I think it's 2 and 3.
2 and 3. Anybody else?
I agree with him. I think it's also 2 and 3.
2 and 3. Where's my book? So Mathangi, what do you think? Do you agree with them, or you think it should be something else?
I agree with them.
Agree? Okay. Well, the answer on this one is C, 1 and 2. What do we remember about the definition of continuity? We remember that the limit has to exist and the function has to be evaluated and that the limit has to equal the function's output value at that point, right? But there was a little theorem I showed you, and I said it was a very important little theorem. And the theorem is on page 144. It says, if the function f has a derivative at a point, then the function is continuous at that point. So for number 1, in order for the derivative to even exist at x is equal to 2, the function must be continuous, right? So that is true. F is differentiable at 2. We know that for sure because the derivative of that thing is 5, okay? So because we got a number, then the derivative exists, so that's true. But did I mention anything about the derivative of f or of a function being continuous at a point? No, I never talked about a derivative being continuous at a point. The derivative is the rate of change of a function at a point or at every point in its domain, so over its entire domain. So derivatives exist at points, and a derivative itself is not something that we deem continuous, right? So the answer is 1 and 2. 3 was a nonsense, kind of an answer choice. So be careful with that, because that's a whole point. All right. The agenda. We're going to wrap up section 2.8. I've already put the entire chapter 2 test review. I don't think you can see it yet. I have to publish it. I have to click a button. But I put it into Canvas yesterday. And so after we go over any homework questions or concerns in the section, And what you guys are essentially going to do today is work on your chapter 2 test review. So I think you guys did 1 through 13 for the first part or something like that. And now what you have to do is work on the rest of it. And we're going to go over the entire review, any questions that you have on Thursday. And then next Monday, you're going to have
Mr. Candidate, please report to the media center. Mr. Candidate, please report to the media center.
and you're going to have a shortened version of a test, which will probably, I don't know if I'm going to do it on Canvas or WebAssign yet. I haven't decided which I like better. But anyway, you will have a time test and it'll be shortened because Monday is an early release day. So anyway, you're going to have a small chapter 2 test on Monday. All right. So were there any questions in section 2.8 that you wanted to go over? Anybody?
16.
16? Which one?
Also 16, but also 18.
18 and 21? Any others? So I have 16, 18, 21. Anybody, anything? All right, so let me unshare this. And let me share my iPad. And I'm just going to open the section in the book and use some paper to on the good notes to do the problem out. So let me just get a new notebook. How's that? New notebook, start. And good, I want paper. So for number, well, maybe I need it. All right, so I'm going to use my document cam. This thing's not sharing anyway. I told it to share and it's not. You are sharing your screen. It's telling me I am sharing my screen. No, I'm not. I'm not sharing my screen. So anyway, that's all right because I need the picture for number 16. So I'm just going to put it under the document camera and we'll do it that way. And so did you have a particular problem or part in number 16 or all of the problems in 16? My camera's not getting big either. What is going on?
For 16, G and H, is there like, so I know that there's a way to get the answer by drawing the derivative graph and just doing it that way, but I'm a little confused.
No, you don't want to do that.
Yeah, so
No, you don't even want to do that. It's, hang on a second, it's too much time wasted. You're not going to have time on an AP exam. Just bear with me one second because something very
wait,
interesting.
never mind, my bad. That was for 18, not 16.
Okay, all right. So yeah, here we want to go. Okay, so this is what I wanted was my camera and I want it to become clear. There it is. Okay, so we have a graph here and the graph is the graph of f, some function. And, you know, we're asked if f is continuous on the interval from -3 to 5. So, right, that's our window that we see. And so is it continuous from -3 to 5? And what would you say? Would you say yes or no? Anybody?
No.
Why not?
There's a removable discontinuity at x equals 3.
Very nice. At x equals to 3, there's a hole in the graph, right? And it's not just a hole, it's a removable discontinuity because if I could pick up this little point and pop it right there, then I could take my pen and go and it'd be nice and smooth and continuous everywhere. So this graph is continuous everywhere on the domain, except for the point where x is equal to 3 because of the removable discontinuity. So that's what you would write. You would write at x equals to 3, you know, this is discontinuous because there's a removable discontinuity at that point, all right? But more importantly, what you need to show the grader is we know for a function to be continuous, so let me get a piece of paper here. I'm going to move this over a bit and I'll put it back in a second. But we know that in order for a function to be continuous, number one, the limit must exist, right? So does the limit exist here when we look at it, when we come in from the left and the right? Does the limit exist? Yes or no? So I don't know who asked this particular question or asked me to do number 16, but whoever did, that's the person I'm looking for. Does the limit exist? If we come in from the left, the limit is like 2.5. That's the height of this hole right here. If I come in from the right side, the height is the same. It's about 2.5. So the limit exists, right? So what I can say is the limit as x approaches 3 from the left is equal to the limit. I know you cannot see that. You know what? Let me pin this, James. Hang on a second. I'm going to go pin my projecting video because you're disrupting with it. Forget to pin it. Pin this video. I'm going to look at Scotty Sheridan's name. Okay. So the limit
What?
as x approaches 3 from the left is equal to the limit as x approaches 3 from the right. And that limit was approximately 2.5. That's a 2.5. All right, so what that implies is that the limit exists. The limit as x approaches 3 then of this function is approximately 2.5. So the limit exists. The second criterion, that was 1. The second one is that the function evaluated at 3 has to be defined. Well, it is. What's f of 3 in this picture? 4. Okay, so f of 3 is 4. So that's fine. What your grader would need you to see is where it fails. So these two, everything's good. The problem is the last criterion, the limit as x approaches 3 of this function has to equal to f of 3. And are those equal? Is 2.5 equal to 4? No. Okay, so they're not equal, and so therefore we would say the point is discontinuous, or f is discontinuous at that point. This is the reason why right here, because the limit does not equal the function output value at that point. Now, in B, it says, does f have critical numbers? So remember, those are the places where the derivative equals 0 or does not exist. And I see 1, 2, 4 critical numbers. I see a critical number at x equals to -3. I see a critical number at x equals to 0. I see a critical number at x equals to 2. And I see a critical number at x is equal to 3, right here. Can anybody tell me why x equals to -3 would be considered a critical number?
I guess the slope of the tangent line would be undefined.
Yeah, anywhere right in here it would be vertical, right? So that's
Mhm.
right. The slope of the tangent line would be undefined there. So that's why at x equals to -3, it's a critical number. Why
So-
is x? Yeah, go ahead.
Places with no limit are critical numbers.
Not necessarily. So, you know, no, that's not true. So places where there are no limits does not guarantee there'll be a critical number. Though I can do a right-handed limit here, right? Because I can't do a left-handed one because there's no graph on this side. But I can come in from the right and I could draw a little tangent line here and it'd be vertical. So it's defined as division by 0 or undefined, all right? So generally speaking at endpoints, the derivative is not going to exist anyway. Endpoints are special, so we leave that for a whole different conversation. But Here, it's clear that the graph is so steep that our tangent line would be vertical, and so the derivative would not exist there, meaning that that would be a critical point. So critical points occur when the derivative equals 0, and or if the derivative does not exist. That's when critical points, or sorry, critical numbers occur. All right, so the derivative doesn't exist here because of the vertical tangent, so that's why that's a critical number. What about at x equals to 0? Why is 0 a critical number?
Direction change, right?
Yeah, direction change of what?
From negative to positive.
But what is going from negative to positive? You have to be very specific. What is going from negative to positive?
The graph.
Okay, can you be a
Or
little,
the function. The function.
okay, a little more specific? It's not just that the graph is going from negative to positive. In fact, the graph is positively valued about both sides of this. So it's not the graph of f that's going from negative to positive. What's
It's-
going from negative to positive?
The slope of the tangent line keeps going back and forth.
Good, very good. Slopes of tangent lines. So if I draw a little tangent over here to the left, it's negatively valued. If I draw one to the right, it's positively valued. And that change in sign is just going to keep oscillating about that cusp. So we wouldn't just say it's because of a cusp, it's because the slopes of the tangent lines have opposing signs about that point. Okay? At x equals to 2, the derivative would be a 0. There's a bump on the graph, right? So therefore, x equals to 2 is a critical number. At x equals 3, that's a critical number because the derivative can't exist there. So back to somebody had said, if the limit does, if the limit doesn't exist, there's a critical number or something like that. I think I have it backwards. But the limit exists here. The limit is 2.5. However, there's a hole in the graph, right? This is not continuous at this point. And so the derivative cannot exist there. So that's why at x equals to 3, we have a critical number. And that was the last one, right? Did I cover them all? -3, 0, 2, 3. Yeah. Does that make sense to everybody? Are there any questions? All right, C. On which intervals is the derivative positively valued? Well, we know the derivative is going to be positively valued when the graph of f is doing what again? You know how I am, I forget. When f is
Increasing.
increasing, good, right? From our little gospel. So the only place I see f increasing is from 0 to about 3. So on the interval from 0 to 3, and by the way, so I've been grading homeworks. It's slow, but I've been grading them. And what I'm noticing is a lot of you guys are not using interval notation, and in calculus, you must use interval notation. So you would want to say from 0 to 2. And you could even put a bracket around 0 because 0 is definitely included. But 2, at that point there, the function goes from increase to decrease at that instant. And even here, the function, even at 0, actually, I wouldn't put a bracket at 0. I'd take that back. Because the function's going from decrease to increase at that point, we would use a parenthesis. And because the function's going from increase to decrease at 2, we'd go to 2. So we'd write from 0 to 2. The other thing you can use, if you don't want to use interval notation, is use of inequality. So, 0 is less than x is less than 2, something like that. Okay. D, on which intervals is f prime increasing? Well, we know that f prime is going to increase when the graph of f is concave up, right? Now, this is very subtle, but this graph is concave up from about here to, I don't know, right around here-ish. Okay, so it's concave up here, and then it goes to concave down, and then it stays concave down for the rest of its life here. So, I don't know if you want to go ahead, you could even say at -2, but somewhere in between here and here-ish, our concavity is going to change. And anyway, I guess I would say from -3, just to make it easy, from like here to here. So concave up and then that's concave down. So from about -3 to -2. And that's how I'd write it. E, identify inflection points. Where are the inflection points, if any? Well, if there's only one change in concavity, there can only be one point of inflection, right? And the inflection point, we already said that the concavity changes at about x equals to -2. So we would say that the point of concavity is at -2, 3, right? So this is the actual coordinates, -2, 3 would be our change in concavity, or our concavity point. So far, so good, everybody? Yes, no, maybe, not sure.
Yeah, I'm good.
Everybody's cool? All right. F. So here's where we get into the limits. So in F, we're asked the limit as x approaches 0. So I can't fit them both in the picture. And I'm projecting it big on the board for students in class so they don't have to look at a device. But the limit as x approaches 0. What is the limit as x approaches 0? Well, before you can find the limit as x approaches 0, you need to show that the limit as x approaches 0 from the left is equal to the limit as x approaches 0 from the right, right? Forgot my functions there. So if we come in from the left, what's the limit as x approaches 0? Gabriel, what's the limit?
0.
Good. And what's the limit as x approaches from the right, Mathangi? Mathangi?
Hi, 1 second, sorry.
What is the limit? I didn't hear what she said. What's the limit as x approaches 0 from the right, Mathangi?
1 second.
I'm sorry?
Do you think you can wait 1 second?
Why?
I'm pulling it up from my homework.
You're trying to what?
Is the limit 0?
The limit 0. Okay, the limit 0. So then we know that the limit as x approaches 0 is 0 then, right? So that's the answer to F. Part G, is F continuous at x equals to 0? Explain briefly. So is F continuous? Well, if this function is continuous at a point, then the limit must exist. Well, we already established that the limit does exist. F of 0 must be defined. It is. F of 0 is 0. And the limit as x approaches 0 has to equal to f of 0. And they're the same, right? They're all 0. So yes, f is continuous at x equals to 0. The only problem is that the derivative is not going to exist there because it's a cusp. In H, we want the limit as x approaches 2 of f prime of x. What does that mean? So Zachary, what does it mean to be asked the limit as x approaches 2 of the derivative of the function?
That means if you take the derivative of the function as x approaches 2, what would the limits be?
Okay. Can you get a little more specific on it? Like, what would you do to solve that problem?
Well, first you would need to find the derivative And then you would also need to find where x is approaching, or where x is trying to get to the limit of 2.
Uh-huh. All right. So what's the derivative at 2?
The derivative at 2 would be negative, right?
Okay, so if I draw a little tangent line here, what's the derivative? Well, that's a bad tangent line. But if I drew a tangent line to a bump on the graph, what's the slope of the tangent line?
1, it looks like.
No, it's 0, it's flat.
Well, that's
My drawing's not that flat, but. So what this is asking is, what is the derivative, or what is the slope of the tangent line at x equals to 2? That's what this is asking. So it looks very similar to all the other limit problems, but you got to be careful because there's a prime here, so it just means what is the slope of the tangent line as x is equal to 2? And we see that it's 0. It would be flat. Whenever you have a bump on the graph, the tangent line to that point is going to be horizontal or flat or 0. Make sense?
Yep.
Okay. What are they asking for in I? Part I. So,
They're asking the limit of the first derivative function when h approaches 0 from the left and the right for I and j.
okay, so kind of. What this is the limit definition of the derivative. They're asking you, what is the derivative as, they're asking you, what is the derivative of this function at x equals to 0 when you're coming in to 0 from the right? And you would say the derivative is, I don't know, let's call it 1 for fun. It's a positive number, right? Let's say it's positive 1. And in J, they're like, what's the derivative when x equals to 0 if you're coming in from the left of 0? And again, I don't know what it might be, but let's just say it's a -1 for fun. Right? So the slope of the tangent line from coming in from the right is a +1. The slope of the tangent line coming in from the left is about a -1. So what do we say about the derivative? What is the derivative at x equals to 0? We say the derivative, what?
Does not exist.
Does not exist. D.
So for I and j, do we, like, is it that simple? Do we need to show any work or anything?
No, generally you wouldn't have to off of graph based off that. Now you could find, you know, little secant slopes or something and estimate it that way. You could find a couple of points, like, I don't know, whatever 2 points you want. But generally you don't have to show work. You just have to justify why it's so. Like here in this last part here in K is where you'd have to justify. And you'd say the limit from the left is not equal to the limit on the right. So even though you don't do any work and like have any numbers there to show for it, you know, the grader would understand that, you know, you understand that too. So that's what matters. So that was 16. In number 18, we have a similar scenario. So let me put the book under there. And in number 18, is A is f continuous on the interval from -4, 4. And again, you have to justify briefly. So is it continuous? I would say no. I see a lot of stuff going on in this graph, right? I see some cusps and I see some breaks and holes and whatnot. And so those are the things I'm going to have to justify. So it's discontinuous. So it's asking, is it continuous on the interval? And I would say, no, it's discontinuous at x equals to -1, at x equals to 1, and x equals to 3. So if we had to justify why it's discontinuous at -1, what would be our justification? What would we write for the grader? Kemwell, can you answer that? Oh, Kemwell's not here. You want? Yeah, go ahead, James. All right, there's a hole, but you need to be more specific. So you need to use mathematics. So in other words, what are the 3 criterion for a function to be considered continuous at a point? The limit has to exist. So does the limit exist? Yeah, it does, right? If I come in from the left and the right, the limit's 1. So the limit clearly exists. Is f of 1 defined? If I plug, or sorry, -1. If I plug the -1 in, no. So f, right, so the limit exists, but the function's not even defined at that point, and so therefore that's why it's discontinuous. We would say that, see if I can find a place to write it over here. We would say that f of a is not defined. What about at x equals to 1? Not f of a, I'm sorry, f of -1. I have a number, -1. What about at x equals to 1? So Yana, could you tell us why x would be considered discontinuous at x equals to 1? You're there, Yana? Dia, can you tell me why?
Is it because the left and right limits don't match?
Perfect. So that's right. That's exactly right. Now you'd have to write that down mathematically, and you would just say, you know, f is discontinuous at x equals to 1 because the limit as x approaches 1 from the left does not equal the limit as x approaches 1 from the right.
But
Yeah.
you have to, like, write it like that, like in.
Yeah, I know it's kind of hard to see. Here, let me go over here. So yeah, you would say the following for a grader. You would say f is discontinuous at x equals 1 since the limit as x approaches 1 from the left of this function does not equal the limit as x approaches 1 from the right of this function. And that would be your mathematical justification. Make sense?
Yeah.
James, what were you going to say?
So if those two limits don't match, the limit would not, the limit for that part, whatever x.
That point cannot exist, right? Mm-hmm.
Right? So that's one criteria.
Mm-hmm. Mm-hmm. Right. And if these did equal, then we could say the limit as x approaches 1 exists, right? So that criteria would be met, but it's not, so you can just stop there. In the next one, so let's see, at x equals to 3, bigger eraser. At x equals to 3, well, let's see. So Shank, can you tell us why we would consider x to be discontinuous at x equals 3?
Because there's a break in the function.
Okay, but you need to write it or state it mathematically, so how would you do that?
There's a removable continuity at x equals 3.
Yeah, you'd get it wrong. Can you try again? What you would have to say is to yourself before you write anything, does the limit exist? Yeah, the limit's 2. Do you agree? If we come in from the left and the right, the limit's the same, so the limit's 2. Is f of 3 defined? Yes, it's 1, right? F of 3 is 1. So the limit exists. F of 1 is defined. And the third criteria is, does the limit as x approaches 3 equal to f of 3? No. So what you would write, so that way you got the point, is you would say, the limit as x approaches 3 of this function does not equal f of 3.
I'm sorry.
Yeah.
Do we have to write this down for the problem right now?
You don't have to write it down right now, but you have to on a test, and you have
We
to.
have to know this like our test.
Oh, absolutely, yeah. Everything you're going to be writing is mostly mathematical, notation and symbols and things like that. And so,
If we got a question like this on the test,
mhm.
and it said explain briefly, would we have to?
This is your explanation, the math. You have to use math to explain, not words. So what he was saying is, right, well, because there's a hole in the graph or because it's a removable discontinuity, it's true, but what AP wants to see is it denoted mathematically. So you're writing in symbols, right? You're writing in the language of math rather than words. So you wouldn't get the points if you wrote out the words. If you said in words, you know, the big long way, the limit as x approaches 3 of this function does not equal, you would not get the points. They want to see the notation, the math.
Okay.
Make sense?
So, but do you want to see that for our homework on this question?
I'm going to want to start seeing it more and more in your homework. Yeah. So that was, oh, that was A. We only got through A.
How did you say we would write it out for -1 again?
Oh, at -1. So does the limit exist? Yes, right? The point's not defined. So you would say that, you know, f is discontinuous at x equals 1. So I'm not going to write that part since f of -1 is not defined. So you are using some words here and there, but they want to see the proper language of math. So math is language all its own. And that's what they want to see your answers in. It's cool stuff. All right, so on to B. Bloop. Here's our graph again. All right, does F have any critical numbers? So Myron, can you tell us any critical numbers that you see on the graph of F? Myron. Okay, let me take a brief pause because I see something in the chat, but oh, somebody wants me to do number 8 or number 11 as well. So I'll do 11. I'll go back and do 11. Sorry. Is it Uran? I don't know. I'm probably not pronouncing your name correctly, and I apologize. But we will do 11. I'll go back to that. So Myron is non-responsive. So Javier, can you tell me if F has any critical numbers? Javier? I'm probably going to mess this name up too, and I apologize, but Muftia?
Hello,
Can you tell me how to pronounce your name?
Muftia.
Muftia? Muftia. Okay, sorry. Can you tell us why or where any critical numbers would be on this graph?
I wasn't exactly sure about this one. I need help on this one too.
Okay. Well, let's see. Critical numbers occur when the derivative equals 0 or does not exist, right? So if we look at the graph from left to right, we already know derivatives don't exist at cusps, right?
So -1.
-1,
And would it also be at the other -1 or no?
Right, and where else?
3. Maybe? I don't know about that.
Actually, yeah, it would be -1, 0, right?
Sorry, I said the -1 of the.
I'm glad that you missed it because a lot of students do miss that. It's right there in front of their eyes, and they, for some reason, you'd be amazed at the number of times students miss something like that. So at -1, we have a critical number because the derivative can't exist there. At 0, right, because the derivative also doesn't exist because the slopes are different on opposite sides. at 1 because we have a break there, right? In other words, the limit doesn't even exist there. And at 3 because the limit exists, but the function's output value is not equal to that limit. So the derivative can't exist there either. So you're on a right path.
I said the other negative one because I saw that it was on the negative one, but I meant to say 0.
Yeah, well, this, and this, right? So there's 4 places here where, yeah.
So points for the graph is discontinuous would be critical points.
Right, because the derivative couldn't exist there. So here we have a cusp, right? And the point's not defined, but if I were to draw a little tangent line just to the left of that cusp and just to the right, the tangent slopes would be different, right? And the same is true at 0. So the derivative can't exist at sharp corners. Here the point's not even defined or anything, so can't exist there. Here the derivative cannot exist because it's not continuous because the limit does not equal the function output value, right? It's a break in the graph. And over here, the limit exists, f of 3 exists, but they're not equal. So a derivative can't exist at 3. So in all those cases, it's never because the derivative equals 0. It's all because the derivative does not exist. Is that okay? In part C, where is the derivative positively valued? Well, we know that the derivative is positively valued. So you see, you're getting the same questions you had in 16, just a different graph, but it's good practice. F prime is positive when F is increasing. So F is increasing from -4 to -1. So I would write from -4 to -1. It's also increasing from 0 to 1. So I'd include that in there. It's also increasing from 1 to 3 and 3 to 4. And why would I state those separately? Anybody know? Anybody know why I would state those separately like that?
Because there's a removable discontinuity at x equals 3.
Yeah, it's not continuous there, right? So if this were to, if this point was defined, if this were all solid, then I could just say from 1 to 4. But right, there's a hole there. So I have to kind of stop and list this interval and then continue with the next interval. So it's kind of like a stop sign.
Ms. Wilson?
Wouldn't you put a inclusive bracket on -4 to -1 or?
No, I wouldn't put, no, I wouldn't put a bracket on any of them. Nope,
Awesome.
nope. You wouldn't get it wrong if you put a bracket, say, from -4 to 1, because this point is clearly there and whatnot, and it's your starting point. But generally speaking, we use parentheses, but either way is fine. You couldn't use brackets on any of these because they're open points. Even here, this is a turning point, so you use a parenthesis from 0. And you could go to 1, but see, the problem is there's a break, and there's another x equals 1 that we need to start at. So that's why you wouldn't use brackets for those ones. Not those ones, but those number ones. You might put a bracket here at 4, but generally, no. But you wouldn't lose a point if you did. All right, the limit as x approaches 3. What's the limit as x approaches 3? We already said it, it's 2, right? The height of the function is 2 when we come in from the left and the right, so it's 2. This one here says, what is the derivative of this function at x equals to 2? It means what is the slope of the tangent line at x equals to 2? So if I go to x equals to 2 and I draw a little tangent line, I don't know, all I need to do is find the slope of this line, right? And the slope of the tangent line is going to be the same. So, I might use the points 1, -2, and 2, 0, and find the slope of that. So m would be 2 over 1, so it'd be about 2. The slope of a tangent line to a linear function is the slope of the linear function itself. And then finally, we want to know what is the derivative as we approach 0 from the left. And I don't know what it is. I'm going to call it -1 again. As we approach 0 from the right, I'm not sure what it is. I don't want to compute it. I'm going to call it +1. So does the limit exist at x equals to 0? Or does the derivative exist? Limit exist? No, right? Are we okay with these now? Maybe I'll just have you do some more section 2.8 practice.
So for questions like G and H, there's really no work that we have to show. We just look at the graph and write it.
The only work you would have to show, so they actually, let's see, let me see. So in AP, it depends, and that's the best I can say. And the reason why, let's see here. Yeah, so the work you would have to do, if it's multiple choice, you don't have to show any work. But the work you would have to do is actually, so I'm being lazy here. I don't feel like sitting here computing the slope of the secant line, all right? You're not allowed to do that on a test. For homework, sure. But on an exam, you're not allowed to do that. So you'd probably have to choose 2 points here and find the slope or estimate the slope of that line, which would be, you know, something that looks like what I just did up here. So it's not much work at all. It's practically no work. And in fact, they're saying that the slope of this is actually more like -2, and this is 2 in the answer key. So, you know, I'm just eyeballing it for the sake of time and convenience, but you would actually have to do the little slope formula for the graders if it were an FRQ. But usually these types of problems are multiple choice. Not all of them, but most of them are multiple choice. So you wouldn't have to show work. On my test, you have to show everything. You have to prove yourselves. All right, so that was 18. Let's go to 21 and then I'll do 11. Another graph. All right, so in 21, oh my gosh, I need like, I just bought like a really good eraser. So, all right, so 21, we're talking about this W looking graph for Wilson. And we have the function G, okay? And this is its graph. It says use the graph to answer the following. So they want you to find G prime of -1. What does that mean? It means what is the derivative of this function at the point where x is equal to -1. So I come here and I draw a tangent line and I say, ooh, that's a linear function, so my tangent line is going to be the same as the slope of the line. I'm going to use the point 0, 2, and I'm going to use the point -2, 0, and I'm going to find the slope, right? So 0 minus 2 over -2 minus 0 is -2 over -2 or 1. So my slope is 1, I would say. It's 1. In part B, for what values of x is the derivative equal to 0? Again, we know that the derivative is, not equal to 0, positive. When is the derivative positive? We know the derivative is positive when the graph of G is increasing. So G is increasing from -2 to 0 and from 1 to 4. Is everybody okay with that? We have a bit of time in AB to slow down if I need to slow down. Again, we do have a huge curriculum to cover. We have a lot to cover before December's exams. So I have a tendency to go very, very fast because we need to be fast-paced in order to meet the curriculum so you can do well on the exam. However, we do have some opportunities where I can slow down a little bit if you're lost in a section. There's going to be a couple of those sections for sure. It happens every year. The hardest concepts of the course where I have to slow down. But if you're a little bit stuck or lost, I cannot stress enough. This first test is going to be a bear. It always is. And you think you get the concepts, and many of you will, and you'll be fine. But there's more than you, more of you who won't. I cannot stress the importance of if there's one little thing that you don't get, or you need extra help with, you need to let me know. All right? There's no shame, there's no embarrassment in letting me know We all need help with something at some point in our lives. There is no kid in this class, in any calculus class, who is just so perfect and above everything that they could look down on any of you. There's not, trust me, I know. So if you have a question, please ask me, and don't worry about what other people think, because it's not about them, it's about you as an individual. And my goal is to get you across the finish line with a 5. I'd even accept a 4, but you know, I shoot for the highest value, a 5 on the AP exam. That way you're not questioned on your college admission. All right, so nobody's saying a word, so I'll just say, okay, you get it. All right, C, show that G is continuous at x equals to 0. Well, how are you going to show? Now that word show is a very powerful word. It means they want you to show. And they don't want you to show with a picture. They don't want you to show with words. They want you to show mathematically. I'm looking for an eraser while I'm teaching. They want you to show mathematically that this is continuous. So what are you going to show the grader? Somebody work with me here. How are you going to show? Scotty, your name's up on the screen for some reason, always. So why don't you answer that question? How would you show the grader that this is continuous at 0? Scotty?
Well, you would have no discontinuities, so you know that there isn't anything wrong with it.
Well, okay, Scotty. So again, we need to demonstrate mathematically because you're not going to get credit for that kind of
Right.
answer. So how would you show that it's continuous?
Well, there is a left-hand and right-hand limit.
Yeah. And what about them?
They equal the same thing, so there's a limit there, which means that it's
Okay.
continuous.
Good. So you would say that the limit exists. You would write that the limit exists, right?
Mm-hmm.
You'd say the limit as x approaches 0 of this function g is equal to 2, right? Okay, what else?
Right.
I see you, James. Go ahead. Yeah, g of 0 is defined and it's 2. And then Scotty, you can finish this off. What would the last thing be that you would write down so you could get full points?
It is right that G is continuous.
What's that?
Would you have to write that the limit of g of x is equal to g of 0?
Nice. The
And then
limit
that
is
equals
x.
2.
Excellent. The limit as x approaches 0 of g is equal to g of 0, which is 2. Therefore, g of x is continuous at x equals 0.
So the first line where you have the limit where x approaches 0 of g of x equals 2, before that, do we need to write like the left-hand side limit equals the right-hand side limit?
Yeah, you could do that. Yeah. But generally speaking in AP on like multiple choice, the questions look an awful lot like number, what was it, 16 and 18, right? You'll have a graph and, you know, you'll be asked one question or a couple of questions, you know, which of the following is true, that kind of a thing. And you'd have to differentiate between those. On FRQ would be where you'd really want to do the writing, free response questions. And you haven't had any of those yet, but you will soon. I'm just getting you prepared now for what to expect very soon. All right, so we've shown that it's continuous. Now in D it says find the limit. Find the limit as h approaches 0. So find the derivative at x equals, or sorry, yeah, x equals 2. What's the derivative at x equals to 2, people? The function's continuous there, but does the derivative exist?
would it be, so it would, the tangent line at x equals 2 is the same, like the slope of the tangent line is the same thing as the slope of the normal function. So you would just find the slope in that like interval of the function, and that would be the answer.
Okay, Rishi. This says, what is the derivative of this graph when x is equal to 2? So, oh yeah, I'm sorry. I was looking I was looking at this 2 here. I was like, there's a cusp there, Rishi. I'm sorry. Yes, at x equals to 2. You know, I wouldn't use this point here necessarily because I don't know what the height is, but I would use the point probably 1, 0 and the point 4, 2 and compute the slope of that, right? So if we use 4, 2 and 1, 0, it would be 2/3. Yeah, that's right. So the slope of the tangent line would be the same as the slope of the line. Then it says sketch a graph of G prime. All right, well, I'm going to sketch a graph. Remember that in AP, when you're asked to sketch, it's just a sketch. So here's how I would sketch it. First of all, I see 3 critical numbers, right? They're all the cusps of this graph, so those are going to be the zeros of my derivative graph. G is decreasing, so F prime is below, right? Then G is increasing, so F prime goes above, but it's going to head toward this 0. And then what do you think is going to happen here at 0? Because you know the derivative doesn't exist here. It doesn't exist here either. So there's going to be holes in the derivative graph, all right? There's going to be a hole here.
Wait, Miss Wilson.
Uh-huh.
How is that the derivative graph? Wouldn't it be, since the slopes are
linear?
Linear. Wouldn't the derivative like also be?
Yeah.
Wouldn't the slope be horizontal?
Right, they would be constants, right? So what I was trying to do, I was trying to give you a quick idea of sketching. Hang on, somebody's coming into the waiting room. What I was trying to do is give you a quick idea of the sketching and then show you that we would have a problem. First of all, because those are linear, but I was getting there, but that we're going to have holes here because the derivatives can't exist at those critical numbers, right? So he's right. If this is linear, and let's just say the slope is -1, then my derivative graph is going to be, this is decreasing, so my slope is negative, and it's going to go here, and there's going to be a hole right here at 2, -2. And then F is increasing, so F prime has to be, or G prime has to be above, and we're going to call this a slope of 1. And so I'm going to have a hole right here, and it's going to go to 1 here, but I'm going to have another hole at 0 because the derivative doesn't exist at 0. And then we said this was a slope of like 2/3, negative 2/3, I think. No, we didn't compute this one. So let's just say it's about -2/3. I'm going to go down about 2/3, put a hole there to 1. I'm going to have another hole here, and then my slope here is about a 1. So another hole and all the way to the end of the function. Does that make sense? Are there any questions?
Isn't the slope of the interval 0 to 1 -2?
Is it a -2? No, go ahead. Hang on 1 second. There's somebody at my door. Yeah, go ahead.
I was going to ask if you ever had patients have an issue with grades. I'm trying to figure out if there's a way, if they're late, automatically go to 50%.
Yeah. If you go into your grade book, there's a little dial that looks like a cog on the right, and it's called settings, and go in there and you can tell it to automatically put the score in there.
Like if it's past its due date, even if it's still
Yeah,
late,
it'll say if late, you know, do you want to give half credit, partial credit, whatever.
So then, but then they can submit it and then I can put in.
It'll put it in the grade book for you as a 0 or half credit or whatever. Yeah. Just do zeros, it's easier. Okay, I'm sorry. So say that again at x equals to, from where to where again? What were you saying?
In the interval, x equals 0 and x equals 1, isn't the slope -2?
Okay, so then if it's a -2, I didn't compute it, but I was eyeballing it, so sure.
And then the interval 1 to 4 would be 2/3.
Is that the 2/3 one?
That's it.
Yes.
Okay, sorry. Looks like a 1 to me. So it's like, so 2/3, so like around here or something, right? Like that, okay. Let's see, that's what I expect on homework and tests, your precision. In BC, we eyeball everything. In AB, we have to be very precise. Okay, so there's our graph of G prime, and then if possible, determine the extreme value. So you didn't have to do that because the IVT, the EVT, and the MVT are all taught at a different time. Okay, so we have 3 existence theorems: the mean value theorem, the extreme value theorem, and the intermediate value theorem. And those guarantee the existence of certain aspects or characteristics of a function, but they don't show you how to find them. And I teach those 3 together. The mean value theorem is not part of this section. You need to, no, you didn't have to do that. I omitted that. And now I'm going to jump back to number 11. And number 11 is easy peasy. So in number 11, you have to find the value of b that makes this function continuous at x equals to 1. So what I said is that you're going to have to do your limits, right? So for this piece here, the values of x have to be less than 1, so the only direction you can come in from is the left. So you'd say the limit as x approaches 1 from the left of negative 2x plus b. This expression cannot be simplified at all. So what that means is you're going to take the limit, and by taking the limit, that means you're going to plug 1 in for every x, because this is the value we're going to. So if I plug a 1 in, we get negative 2 plus b. All right, so you're done with that part for now. In the second, we have the limit as x approaches 1 from the right, because all the values of x have to be greater than or equal to 1 of ln x. And I can't simplify this expression anymore, so again, I'm going to take the limit by plugging the 1 in. And what is the ln of 1? It's 0. Okay, natural log of 1 is 0. So what you're going to do is you're going to take this and set them equal and solve for b. So you have, b minus 2 equals to 0, so b equals 2. And what that means is that the value of b that will make this function continuous is 2. And that's it. That's all you have to do. Does that make sense to the person who asked?
Yeah.
Okay. All right. So it's not that bad of a section, in my opinion. It's a very simple and elegant, yet very powerful section, because our derivatives that we're going to study once we get out of chapter 2 are dependent on the continuity of a function. So it has an oomph to it. It's very important. Okay. In fact, everything in chapter 2 is very important to the future study of our derivatives. So, and you're going to kind of forget about chapter 2 for a while once we leave it, and you're going to be so happy until we have to start doing applications, and then it's going to be like, oh, I forgot all this stuff from chapter 2. So, your syllabus in college will say, you have a 3-unit class, right? That means you attend class 3 hours per week. And every syllabus says at minimum, if you're doing well, each hour of time in class, you need to spend 2 hours outside of class studying. That's why a 12-unit workload in college is equivalent to a 40-hour work week. So even if you're doing well, you still are required to study 2 hours per unit. So that would be 6 hours a week in addition to the 3 hours you spend in class. So you got 9 hours technically of work time in order to be successful at the class. And if you're doing your 6 hours of study time and you're still struggling, then that means you have to put in more study time and more study time and more study time with a tutor and a book and a this and a that. And so the rule of thumb is 2 hours outside of class for every hour in class. You should be studying. So you should always be referring back to prior knowledge in a calculus class in order to be successful. So we don't learn it and forget about it forever. We learn it and we kind of forget it. We don't forget about it, but we don't use it for a while. And then it comes flooding back in. So it's really important to know. All right. Are there any sections in chapter 2 for which anybody is just going stir crazy over, where it's very difficult, or your very worst section thus far. Maybe it was 2.8, maybe it's 2.2. I don't know. You have to tell me. Anybody have any words or, want to discuss anything like that where I could do a quick mini reteach or something like that? Hang on, my phone's ringing now. As if there aren't enough disturbances in the school day in the land of the mighty tiger. What? Did we put her? Hello? Hi. Yeah. Yeah, thanks. For my class, tell me that I'm prospering. I'm not a baby. I'm becoming hostile. Okay, so anything that anybody has in mind? Any section you want extra work in, extra practice in?
Could you post a video of you doing some more problems from 2.8?
From 2.8, yeah. I'm gonna have to make a video, so I'll do that. Section 2.8, more practice video. You're talking about with the graphs and whatnot? Is that what your main concern is? Graphically speaking? Okay. Graphs. All right. Anybody else?
Honestly, I think just another like chapter 2 review. I don't know if that's already in the plans, but
And in fact, so let me go into Canvas right now. And if I can get into Canvas. So Canvas has been acting a little strange again the last couple of days. I don't know if it's Clever or if it's Canvas, but you can't they're connected. And it seems like when Clever has an issue, then Canvas has an issue, and Clever's been having issues. So maybe it's not Canvas. Of course, you don't have to ask, you can just go. You have a card. Just put the little thing in the door so you can get back in. I know. Polite children. It should be over there somewhere. You can stick a pencil in the door or whatever. There's a pencil cup over there. So let's see, block 1. Let me go to your modules. And let me see if I can find your review. And there's your 2.8. Huh, it didn't copy in yesterday to your class. Unbelievable. I had trouble yesterday. I was copying it to 1, 3, and 5, and it copied into 3 and 5, and for some reason it wouldn't copy into 1, and I thought it finally copied in. I checked it. So let me just go back here. And that's exactly what you're going to do. So I posted the full chapter 2 review for extra practice, and that's what you're going to work on between now and Thursday. And then Thursday, we're going to go over it together, all right, from the beginning all the way to the end to make sure you understand it. Unbelievable, this thing. Okay, so I'm going to transfer it over right now because it didn't transfer. So give me a minute. I'm going to do that, and then you can go into modules. I'll let you know when the transfer is complete. So just bear with it. Take a stretch break or something for a minute. Okay, you guys should be able, if you go into assignments and you look under chapter 2 homework, I put it right at the top. It's called chapter 2 review. You should click on that, and then there's a link for the document. And if you have any trouble opening it or reading it, let me know, because it's taking a long time to load. But this thing's really getting on my last nerve. Some of the formulae don't seem to like to come up under, if I put it as a PDF. So it's in it as a Word document, but I understand some of you have Macs, and so you need PDF. So if you need PDF, let me know, and I'll include one anyway, but if you have any trouble where the formulas are missing, I don't have time to scan every little iota of it, but you need to let me know, or if the graphs don't show up or something. So the Word doc's opening, it just takes a minute to open for some reason. And you should be all set for that.
Miss Wilson, it shows that we have 2.7 homework due at 10 a.m. Is that the homework that there wasn't a submission for earlier?
Yeah, so I didn't assign you homework for 2.7, right? Was you?
Yeah, you did.
Was that?
You assigned us homework for 2.7, but there wasn't a submit button.
Oh yeah, I fixed it. So somebody sent me an email, so I fixed it. I think I fixed it. So anyway, that would be the submit button then. I think I received an email that there was no place to submit the work. So yesterday I went in and added it. So you can just put it there. You'll be good. Also, you should know that the answer key is on the last page of the review. So you can check to make sure you're on the right path. And if your answers are wrong from what's on that key, then you need to let me know on Thursday so I can go over those with you to make sure you understand how to do the problem. Okay, I'm uploading the PDF right now. Oops, PDF version. Okay, there they are. So you should be all set. I want to know, did Yana return to class? Is Yana here? Yana? And how about Myron? Is Myron here? All right, get to work. Do your chapter 2 review.
Miss Wilson,
Yeah, yeah.
I saw you put in an assignment for 2.7, and I thought you said that we didn't have to do it.
Okay, so that's what I was asking earlier. There was one class where I didn't assign the homework. I didn't give you a 2.7 homework assignment. So you didn't have to do it. Now, if you're that class, then you don't have to do it. But if you were not that class, because you're not all at the same place, I've got a group of kids who are just right on the ball and everybody does really well. So I let that class skip it. And I don't remember if it was this class or not. I've got it written down in my book, but I left my book at home, my planning book this morning. So James, did I tell you you could omit section 2.7? Did I not assign a section 2.7 homework for you guys for this class?
I don't believe you assigned it to.
Okay,
I
so,
don't remember you assigning it to this class.
okay, all right, so, right, then you do not have to do it. It's just copied there because I copied it to, I always copy it to more than one AB class to cover everything. That's why. So disregard it.
All right, thanks. I just wanted to make sure.
No, I'm glad that you brought it up. Thank you.
Can we get like credit if we did do it? Because I still did it.
Yeah, I'll put it in as an extra credit, but it has to be in by like 10 this morning or something.
Yeah, I've already turned it in.
Oh, okay. Then yeah, I'll give you extra credit.
I have a question on my
Big deal. Hello, everybody. Let me look at the waiting room. So that's strange. There are only like 3 kids online in the class. I know not that many are testing because I have a testing roster. But, oh well. So report of the day is up there, and I'm going to transition into a bell work. So we'll go over the bell work. We'll go over our agenda for today, and we did go up to 2.8 in this class, yes? Last homework was section 2.8? Okay. So we'll cover the agenda and go over homework if you have questions from the section. So try and answer this question. This is a 1997 AP Calculus AB multiple choice question. Oh my gosh. While I take the attendance. So let's see. Christopher cannot be here because he just left. So I have to have him, Shreya. Let's see. What else is online here? Room. Carson's here. Ellen's here. Marie is here. Angela. Alexa's here. Isaiah is here. I love that name, Isaiah. Andrew. Chatana is absent. James is absent. Joshua is here. Isael. Wow, Christopher, you made it. Can't believe you made it. Cannot even believe you made it to class, Christopher. That's dedication for you. Aaron is absent. Ellen is absent. Matthew's here. Ethan. Vivian is not here. I know it's kind of hard to see from the back, and maybe, let's see. Maybe, oh, I didn't want to show you that one yet. I'm trying to get off the PowerPoint. There we go. So maybe I can just make it bigger and then project it, this slide, and see if that helps. Is that any better? Yeah. That's about as big as I can make it. I'm going to have to try and make the questions when I click them the size of the slide, but that's not always easy to do. Shatana's here, tardy. Anybody have an answer? One. Either in class or online. Yeah, Andrew? Okay, Andrew says it's A. Anybody have a different answer? What did you say, Carson? Oh, okay. Well, maybe you're right. Who knows?
I would think B.
You would think B too? How about online? So maybe Chatana, which answer choice do you think is correct?
Miss Wilson, I didn't even read the question yet.
Okay. So how about then, let's see, who else is here? Online. Isaiah, what do you think?
I think a lot of things.
I'm talking about pertaining to this question.
Good question.
What answer choice would you pick? Johanna, have you decided yet?
I'm thinking about it. I'll have an answer for you in like 1 minute.
1 minute's too long. All right, so let's have a look.
I think it's B.
Okay. So we have 3 B's and 1 A. Let's see who the winner is. And you get prizes. All right, this is the graph of the derivative. So if this, so what we're looking for, since we're looking at the derivative graph, is the zeros of the derivative, right? I want to see how the derivative is changing signs about the 0. So to the left of this 0 here, this critical number, the derivative is negative, and to the right it's positive. Well, what do we know about a function that whose derivative is negative? What's the function doing? Decreasing, right? And when it goes to positive, then the function goes to increase. And so we would expect there to be a relative minimum at that 0. Does that make sense to everybody? Okay, over here, it's just the opposite. The derivative goes from positive to negative. So that means our function goes from increase to decrease. So the top of the mountain is a relative minimum. So right now we're 1 for 1. And over here, this 0, we're going from negative to positive again. So it looks like there's 2 relative minimum and 1 relative maximum. So A is the correct answer. Capiche? So those.
Wait, Wilson, how did you get relative minimum for the second one?
Okay, the derivative is negative to the left, right? Which means the function is decreasing. And then the derivative is positive to the right of that 0. That means the function goes to increasing. When you go from decrease to increase, you got the bottom of the bowl, so it's a minimum. Does that make sense?
Can you sketch that?
Yeah. Let me go off of this. Now, here's the thing. Let me take a picture of this. I'm just taking a picture of this screen. And let me take a picture of the next one too, and I'll just stay on my iPad. But I have to do weird things to do it. So snapshot, save to photos, done. All right, so I'm going to stop sharing this screen and I'm going to start sharing my iPad screen. So we're going to, let me go to photos first, select my, I know, it's going to be a sec. So let me go to the first one and the second one. Done. All right, so now I'm going to share my screen. Oh, shoot. Here we go. So let's go to my photo and let's look at this one here. So can everybody see that okay? I know for those of you in the room, here's the thing. Can I write on the photo? No. So, oh, okay. All right. So edit. Thank you. I learn something new every day. All right. So what's going on here is this is the graph of the derivative, right? And what we know is that, now let's see, am I on a pen here? No.
Miss Wilson, if you click like the 3 dots up in the right-hand corner, then it'll say like markup, and you can click that and it'll let you draw on it.
Oh, up here.
Yeah.
Okay, markup. Okay. Okay, let's try this. Here we go. Here's the pens. Thank you. All right, so I'll use blue ink. And so remember that when the derivative, or when a function is increasing, our derivative is positive. And when a function is decreasing, our derivative is negatively valued, right? And so when the derivative goes from positive to negative, it can only do that on the x-axis, right? About a 0. So we have a 0 here, we have a 0 here, and we have a 0 here, right? Critical numbers. So the derivative to the left is negatively valued, and to the right of that critical number is positively valued. So what I know is my function for this at this point here is going to go from decrease to increase, so I'd expect a relative minimum. Do you all agree with that? Over here at this 0, my function is positive above, my derivative is positive above and negative below. That means my function is going to go from increase to decrease. And since that's the top of the mountain, I would expect a maximum there. And then over at this other critical number, this other 0 here, my derivative is negative to the left and positive to the right. That means my original function is going to go from decrease to increase. And so we're going to have a relative minimum at that point. Is that okay? And as such, the correct answer would be A. 2 relative mins and 1 max. Now, when I was grading some of the homeworks, I noticed, and trust me, I didn't even put a dent in it because I'm proctoring 2 days this week. If I'm not proctoring, I'm doing duty. If I'm not doing duty, we're in a meeting. It's been unbelievable. Like, I'm at my wit's end with losing time to grade. So my little rant. But I have been grading little by little. And what I'm noticing in the homework is some of you are actually, you get this, okay? You understand this, but this is what you're given as your answer. And AP does not accept pictures, okay? They will not give you a point, no matter how accurate or beautiful your picture is. You don't get points for pictures. So what I want to tell you is that when you're talking about anything in AP, number one, you need to describe it mathematically with as few words as possible and 0 pictures. So, you know, if I had to, you know, if the question were changed to perhaps, you know, does this function have a relative max or min at whatever this point is here, right? Point X. I couldn't do this. That would be bad. I would say, you know, that F has a relative minimum at X equals A, since F prime is negative to the left. This is probably the most writing you're going to have to do in AP, and F prime is positive to the right. Now you notice I'm not using the words negative and positive. I'm using mathematical symbols. That's what AP is going to want to see. All right? So just keep that in mind. I'll keep correcting you, trust me, as we go. All right, the next one. So let me be done with this thing here. And let me, I guess, done. Here's the next picture. I have to find my 3 dots, I think. I don't see them anywhere. So help me, huh?
Go to edit and then you get the 3 dots.
Edit. Thank you. Okay, so the 3 dots and markup. Okay, there we go. So here's the second one, and I'm gonna flip my iPad around. So here's another AP Calculus AB question that I wanna make you think about here for a second. So we've got a function such that the derivative at X equals 2 is equal to 5. And the question is, which of the following must be true? 1, 2, 3, a few of them, or all of them? Mull that over for a second. What do you think? So Joshua, you have an idea? I'm sorry. D, maybe. 1 and 3 only.
I think it may be C.
C, 1 and 2 only. We have a D, we have a C.
And some get D.
You're getting D? Okay. Let's see, Brian's not here. And Ethan. Should I reveal? Okay, what I know is this. The derivative of this function, whatever the function is, exists, right? In fact, it's 5 because they told you it is, right? So by giving me a number other than D and E, that means the derivative exists at x equals to 2. And what we learned last time is that a function, if a derivative exists, a function is continuous, right? At that point. So I know at the point x equals to 2, my function is continuous, right? So number 1 is true. F is definitely continuous at x equals to 2. Is number 2 true? F is differentiable at x equals to 2. Well, if the derivative exists, then it's differentiable, right? Differentiable means you're able to take a derivative. So since this is differentiable, and we know that because we got the derivative value, it's 5, then this is true. These two are true. Now, I wonder, what part of the last lecture did I state that the derivative of a function is continuous? Did I say anything like that? No, I didn't. All right, so a function can be continuous at a point or at all of its points, right? If I have a nice smooth polynomial, it's differentiable everywhere. It's continuous everywhere on this graph. Even this one, right? Absolute value of x is continuous everywhere on its graph, but is the absolute value of x differentiable everywhere? So is the V-shaped graph differentiable everywhere? No, why not? Good, there's a corner or a cusp, right? So if we think of, the absolute value graph, oh, that's weird, like a crayon. There's a sharp corner there, and we know that the derivative cannot exist at x equals to 0, right? But it's continuous everywhere. And it's differentiable everywhere except x equals to 0. So a derivative can exist at a point, or it can exist at every single point in its domain. Not this particular function, but in a function. But the derivative itself is not a continuous thing. It's a rate of change at a particular point. Okay? So this one, no. So the answer would be C at 1 and 2 only. Does that make sense to everybody here and online? All right, now I'm going to go back to screen sharing on the other computer because, well, let me get out of this thing here. Stop. Because my PowerPoint's here and they don't transfer over into GoodNotes very well. So let me go back to a screen, share my screen. Here we go. So our agenda for today. So we did a couple of BellWorks, and you'll get better at those as we move along. These are your very first AP type questions, and you're not used to it. So, you know, if you didn't get it right, it's okay. That's what BellWorks for, to kind of make you think and think about how to answer things. You will get better at it with time. However, we want to go over any homework questions you have. And since 2.8 concludes the chapter, that means we need to have a chapter test, and that's going to happen next week. So I have the rest of the chapter 2 test review in your Canvas. You just can't see it yet. And after we go over 2.8 questions, then I will unleash the chapter 2 review, and you're going to work on that during the class. And I'll help you with any questions that you have or concerns at that point. So are there any questions on the section 2.8 homework that you would like to go over?
I had one.
Okay.
Number 18F.
18F. People, I'm warning you, you need to tell me now if you need help on something, because it's really important that you understand what's going on. I can't stress it enough, because when that test comes, it's going to hit you like a ton of bricks. It's a hard test. Most of the students, when they complete calculus, will say the chapter 2 test was the most difficult test they had to take. Well, there's a couple others, but that one was by far the most difficult. So I've given you all the concepts, I've covered everything, but when it's time to recognize them and apply them, that's not always that easy. So, you know, it's really important to me that you understand what's going on, because I want you to do well on the test. So if you have a question on any other problem, please tell me. Please tell me. Number 18F is the only question. Oh, I'm sorry, Andrew. Yeah. Okay. Any others? Yeah. 21. B. E. Any others? All right. Well, if you think of anything, let me know. So I'm going to work these in order. So I'm going to start with number 16, and we want to do F, I, and J. So am I in 2.8 here? Is this the 2.8? It is. Okay, so let me get rid of my jargon here. And let's have a look. All right, so this is the graph for number 16. I'm trying to make it as big as I can. And what I'm going to do is I'm going to open my book so I can focus on the graph, and then I'll kind of state what the problem is, and we'll work on it that way. So 2.8, here we go, number 16. So in F, problem F wants to know the following. So let me move this over a little bit. So those of you in the back, you can see this okay, right? You can see the graph okay? All right, so the question for F is, what is the limit as x approaches 0 of f of x? What does that even mean? Can somebody tell me what that means? So Paris, can you tell me what that means, the limit as x approaches 0 of f of x?
So you would look at the point where it's 0, and you would see where both sides meet the 0.
Perfect. That's right. So remember, guys, for a limit to exist at a particular point, you have to show that the limit exists both from the left and the right, and if they're the same number, then we say the limit exists. So what you would say, what you would have to write for a grader is you'd have to say, you know, the limit as x approaches 0 from the left of this function. Well, if we come in from the left, what's the limit? 0, good. And then we would have to show the limit as x approaches 0 from the right of this function. And if we come in from the right-hand side, we say the limit is also 0. And if the limit from the left equals the limit on the right, then we can say that the limit as x approaches 0 is also 0. Okay? So that was F. And then in I says the following. They want you to find the limit as h approaches 0 from the right of f of 0 plus h minus f of 0 all over h. Now, can somebody tell me what this means? Because there's a difference between this one and this one. Yeah.
Line that's going towards the limit.
Good. We're looking for the slope of the tangent line, or the derivative at x is equal to 0, right? Yeah, so is the derivative or the slope of the tangent line, they mean the same thing, right? So as we're approaching 0 from the right, so what you would have to do there is maybe choose the point 0, 0, and some other nice little point, like, none of the points are nice. I don't know, maybe 1, 2.5 or something, right? And kind of estimate the slope of the secant. I'm estimating because I'm not sure if that's actually 2.5. You know, and I would say m is equal to 2.5 minus 0 over 1 minus 0. So the slope's about 2.5. So here they're asking me, what is the slope of the tangent line when x is equal to 0? Does that make sense? Are there any others from anybody in that section, A through K, that, yeah.
So on the left side, it also asks what's the derivative of
Yeah.
the limit on the left side.
Yeah.
It looks like it gets really steep right there as it's
Yeah.
turning into 0. So what would you, if they ask that, would they ask that question on the test, and if so, what would you do?
They could.
Because it's getting pretty steep.
All right. I don't know if it'd quite be that steep. It doesn't look that steep to me. It looks like maybe between a 1 and a 2, maybe a 3 somewhere, to be honest with you. But again, you know, you might choose the point 0, 0, and maybe the point -1, 2, right? And you're drawn, remember, a little secant line is going to pretty much approach the tangent line at that point. But anyway, you know, it looks like a slope of about -2-ish. So the limit on the left is a negative, right? The limit on the right is a positive. And again, this is why the derivative for part K, when it asks you in part K, it says the limit as x approaches 0, f prime of x equals, well, we would say it does not exist, right? Because the limit on the left does not equal the limit on the right. Now, we're talking this about limit notation. This is the limit definition here of the derivative. But remember, limits and derivatives are a little bit different, okay? And derivative, in this sense, we're thinking, what is the slope of the tangent line to the point? And definitely that derivative will not exist because the slopes of the tangent lines to the left and the right are not the same.
Ms. Wilson, so you're saying that when it asks for the derivative from the, so the limit from the right and the left, and like the derivative of those points, then you take the actual slope of the line?
Correct. So in this other notation here, so I'm just going to minimize the graph because it's kind of irrelevant for what I'm about to say. But, you know, when you're asked to find, well, actually, let me put it right about there. When you're asked a question such as maybe, you know, what is the limit as x approaches -1 of this function? Well, you would check, you know, the limit from the left, and as we get close to -1, you say it's 2, right? The height is 2. And when we come in from the right, the height is 2. And so we'd say the limit is 2. Do you agree with that? Hello?
Yes.
Okay, so you're okay with that, right? So what we're doing is we're finding the height of the graph as x gets really, really close to but not equal to a particular point. In this case, namely -1, right? In this, first of all, this is as x is approaching a number. This is as the width of the interval is getting small. You see the difference right there between these two? And also, this whole thing is the derivative of a function at the point where x is equal to a, right? That's what this thing represents. This does not represent the derivative. This represents the height. This one here represents what is the height of the graph, or what is the function approaching as we get really, really close to -1. This is what is the slope of the tangent line, or the velocity, or the derivative. We use those words interchangeably at the moment when x is equal to a. Do you see the difference now?
Yeah, because I originally put does not exist because I thought it didn't exist at a cusp, but now I get it because you're saying it's like you take this slope.
Okay, no, you're right. The derivative does not exist at the cusp. And the reason why is, look, the limit exists at the cusp. Do you agree? The
Yeah.
limit from the left was 0, the limit from, so the height of the graph is 0 at the cusp. So the limit exists. The derivative doesn't exist, and you are correct, because the slope of the tangent line to the left is negative and to the right is positive. And the closer and closer we get to this little cusp, the slopes are still just going to oscillate between positive and negative. They can never get to be one particular number. So because of that, the derivative can't exist at the cusp. So you were right, it doesn't exist there.
Yeah, I mean, I get that now, but it was just like from the right and from the left, I was confused as to like why it was does not exist, but now I get it.
But now you get it, okay. Anything else from that problem, anybody? All right, so that was 16. So let's go to 18F. And is this 18? Yeah, 18 is very similar to 16, same, different graph, but same type of problems.
Wait, Ms.
And-
Wilson, I have one more question about that.
Yeah.
So what if there was like, what if it was like -2 on the left, but +2 on the right? It was the same number, but it was just like negative and positive. Would that still mean that the limit as x approaches 0 of f prime does not exist because they're two different signs, or would it mean that?
Right, because the signs are different. So in other words, you agree with me if you think of a number line, right? Oops, I need a pen here. If you think of a number line, -2 is not equal to +2, right?
Yeah, okay.
They're not the same. They have to be identical in sign and number. Okay, so in 18F, what are we being asked here? We're asked, what is the limit as x approaches 2 of f prime of x? Well, what this means is, what is the slope of the tangent line as x approaches 2? This is just a different way to write it. The other way you would have seen it was the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Okay, these two things mean the same thing. What is the derivative or the slope of the tangent line or the velocity of this function at the moment when x is equal to 2? Is that okay? So I want to know what the slope of the line is. Well, if I look at where x is equal to 2 and I put a little tangent line there, it just is the same. So here's a little prelude or preview into chapter 4, which is where you go after you pass this test. The slope of the derivative of a linear function is the slope of the linear function itself. So if I can just find my internet connection was lost. If I can just find the slope of this line, I'm good. So I'm going to choose two nice easy points on the line, such as 1, -2, and 2, 0, and compute the slope. So m tangent is equal to 0 minus a -2 over 2 minus 1. So it looks like the slope is 2. So I'd say this is 2. Is that okay?
Yes, that makes sense. Thank you.
Anything else for 18?
Where G and H does not exist? Because there was like the answer key doesn't show 18.
Okay, careful there. So in G,
Oh wait, now it's not. No, now I see it's not. Does not exist. Right. Okay.
these are one-sided, right? So, you know, does the derivative exist on the right of 0? Well, sure it does, right? It's whatever this, maybe that's a 1 or something. You'd have to compute the slope, right? And on the left of 0, on this side, maybe it's a -1. It's probably not quite -1, but anyway, yeah. So the left and right-hand limits are going to exist, but the left and right-hand derivatives are going to exist, but the derivative at this point here is not going to exist at the cusp, because the limit from the left doesn't equal the limit on the right. And it's not about the limit that the derivative doesn't exist. Remember, this function is continuous, right? And in order for a derivative to exist, the function has to be continuous, right? And this function is continuous, but the derivative doesn't exist because at a corner it just kind of oscillates back and forth between positive and negative, whatever the slope is. So, or they could be completely like off the wall different. That's number 18. And now we're going to go to 21. Ooh. 21. Nice problem. So I'm going to make the graph big because we're going to be working with the graph. And I will ask the questions and you guys can chime in and let me know. So in 21, it was 21E that was the question. They wanted us to sketch a graph of the derivative. So I'm going to do that in red. Unless anybody has questions from part A through E. All right, part F.
Did you do actually like all of 21?
Yeah. So in part A, they wanted you to find G prime of 1, right? So in part A, they wanted G prime of 1. So that means what is the derivative when x is equal to 1, right? So what would you say? I'm sorry, negative 1. They wanted G prime of negative 1. Negative 1. So what's the derivative when x is equal to negative 1? Well, again, if I put a little tangent line there and I draw it, it's going to be coincident with the linear function. So I just have to find the slope of that linear function. So I might use the point 0, 2 and the point negative 2, 0. Make it nice and easy on myself, right? Use the intercepts. So the slope, or I'd say G prime of 1, is equal to 0 minus 2 over negative 2 minus 0. And so what is that, a positive 1? So I'd say the slope is 1 there. And you probably could have eyeballed that and figured that out, right? So that's A. In B, they want to know for what values of x is the derivative positively valued. Okay, so for part B, when is G prime of x positively valued? Well, we know that the derivative is positive when our function is increasing, right? So I would say from negative 2 to 0 in interval notation and from 1 to 4. I wouldn't use brackets at negative 2 or 0 or 1 because kids were asking me that last block. Why can't you just use brackets? Because those are turning points, and so at one split second it's negative slope, and the next split second is positive or decreasing and increasing. So whenever there's a turning point, we'll generally just use parentheses and not brackets. All right, so when G is increasing, our derivative will be positive. So that's that. In part C, they want you to show that G is continuous at x equals to 0. Well, how do we show that a function is continuous? Number one, we have to show that the limit as x approaches 0 of this function exists, right? And so let me write it up here actually. So I need to show that the limit as x approaches 0 from the left of this function is g, right? They're calling it g, of g of x is equal to the limit as x approaches 0 from the right of g of x implies that the limit as x approaches 0 of g of x exists, right? And what it's equal to. So if we come in from the left, what's the limit? If we come in from the right, what's the limit? Also 2. So we know that the limit exists because it's 2. Is that okay? So we've checked off our first criterion here, right? There's 3 criterion for continuity. The limit has to exist, the function has to be defined at the point, and the limit at that point has to equal the function output value at that point. So the limit is 2, so we're good here. So second, is f of 0 defined? Well, what is f of 0? It's 2, right? So we're happy there. That criterion is done. And you notice I'm not writing this out in words. I have to write it mathematically. The grader is going to expect to see this on your paper or you won't get the points. The grader is going to expect to see that on your paper or you won't get the points. Finally, the third criterion that we have to show is that the limit as x approaches 0 of this function is equal to g of 0. And is it? Yes, we decided that it's defined. F of 0 is 2 and the limit is 2. And so we've shown that. Is that okay? Questions, concerns, misery? All right, in the next problem in part D, they want you to find the limit as h approaches 0. So right away I know they're talking about what is the derivative, right, of g of 2 plus h minus g of 2 over h. And we want the derivative more specifically when x is equal to 2. So I come over here and I draw a tangent line and I say, ooh, I just need 2 convenient points. Well, I'm going to use the point 1, 0 and the point 4, 2. I'm going to compute the slope to the best of my ability. I have 2 minus 0 over 4 minus 1, or 2/3. So the slope of this line is going to be the same as the slope of the tangent line, and it is 2/3.
When do you care that the intervals are the same on either side when you take points?
When do I care if the intervals are the same?
Yeah, I just remember you saying that you have to make sure that the intervals away from the point you're trying to estimate are the same.
Oh, that's when you're estimating using slopes of secant lines. So this is a nice linear function, so it's really easy to find the derivative because the derivative is the same. So if I know the slope of the linear part of the function, right, the slope of the tangent line all along this interval is going to be the same. It's going to be 2/3, right? Whether I choose, you know, if I make my tangent here or here or here, it doesn't matter. They're all going to come out to 2/3, right? But when you have something curvy, so like this one, you know, suppose I wanted you, so let's just suppose that, so bear with me. So pretend this dot was filled in, right? There was no weirdness there. And I wanted you to find f prime of 3. Well, the best thing you could do is you'd take a point of the same interval width and compute the slope of a little secant line there, right? And then you'd go to the right, the same width of the interval. So that'd be like right around here. This one's a hard one. I picked terrible, but these two distances are about equidistant, so that's about the same as 1 unit width. No, it's not. I can't see going downhill. So yeah, from here to here is 1 unit, right? And so in other words, my widths are the same, and I'd find the secant line here, and then I would average them together. So that's when you want to do that. You want to make sure your horizontal widths are equal. But in a graph like this one, like 21, you're not doing secant lines. You're just drawing little tangent lines and computing the slope. Does that help?
Yeah.
All right. So, and then in part E, you're asked to sketch the graph of G prime. Easy peasy. Okay, what I know is that the derivative is not going to exist at any of those cusps, right? In other words, I'm going to have a hole in the graph. And since each one of these pieces is linear, my derivative is going to be the same as the slope of this piece, the slope of this line, the slope of this line, the slope of this line, and those little critical numbers there, or cusps, I'm going to have 0. So in other words, I'm going to have open circles in the graph. So whenever you're graphing any kind of a graph, a derivative graph from a linear function, it's going to be, you know, with these circles, it's going to be very broken up, all right? And here's how you figure it out. The slope of this line, I think, is about a -1. Now, I'm just making this up. I don't know if it's really -1 or not, but it looks like a -1 to me. So the derivative would be, I'd go to y equals to -1 all the way to the cusp and put a hole there. You okay with that? So for a linear function, the derivative graph is just representing the height, or the slope of this function is represented as a height on the graph, on the derivative graph, a constant height. We all know that the derivative of a linear function is a constant, right? We drop a power. So they're all going to be flat lines wherever I draw them. They're just going to represent or go through the y equals whatever the slope is. So for instance, on this one here, I'm eyeballing it again. I'm not actually computing the slope, but I'm going to say that's a slope of 1. So I'd go up on the graph to where y is equal to 1, and I'd start with an open circle for the cusp, and I'd go all the way to 0, and I'd end with an open circle for this cusp right here. Is that okay? And then for this next piece here, I don't know what that slope is, but it's definitely not -1. Let's say it's -2-ish. Again, I'm eyeballing. So I'm going to go down to, I'm going to start with an open circle, and I'm going to go to that next cusp and end with an open circle. And then I forgot what we said this slope was. Was this the 2/3 one? Is that the one? 2/3? Okay, so that means I'm going to go up about 2/3 from this cusp. I'm going to have an open circle all the way to the end and end. Actually, I don't need an open circle on the end of that. So it's going to look, so this about 2/3 is going to look kind of like that. If you take physics, when you have to do, you probably have to graph some velocity / acceleration graphs. Your acceleration graphs are generally very broken and constant like that. Some of you may remember that if you took a physics class. So that would be the graph of the derivative. Beautiful, isn't it? Any other questions from section 2.8? Anybody? 13, yeah. Let's see, where's 13? Yeah. So let me erase this other stuff. So remember, this is going to be just like all the other ones, right? Where what we're going to do is we're going to take the limit from the left and the right of each piece, and we're going to set those results equal to each other and solve for b. So on the left-hand side, we're going to have the limit as x approaches 1 from the left of x plus b quantity squared. Now, I can FOIL that out if I want to, but even if I FOIL it, is it going to be, can I simplify it anymore? No. All right. So if that bothers you, you can write this as the limit. Well, actually, let me just get rid of that. So to save room, if I FOIL that out, it's going to be x squared plus 2bx plus b squared, right? And the question is, can I simplify any of this anymore? No. So when you can't simplify it, you take the limit, and that means you plug the 1 in for every x in the function. If I plug a 1 in, what I get is 2b plus b squared plus 1. Does everybody agree with that? So I'm going to write it in a descending order. So I'm going to have b squared plus 2b plus 1. And I'm going to hold this thought here for a second, right? Oh, did I lose my internet? What? You see, this is what Canvas does. It just goes on and on. So let us wait for a second. So when I upload the video tonight, this happened yesterday too, you're going to get 2 parts to the video. Annoying. Oh. Share screen. What I'm impressed with is that it goes right back to Zoom, which is weird. So I don't know if it's actually a Zoom thing or a Canvas thing. Come on, baby, you can do it. There we go. And I got to go up and fix that thing. That. All right. Go back into my bubble. I love working in this bubble. I hope I get to work in the bubble for the rest of the year. I feel very safe back here. Maybe I'm not. All right. So is that okay? That so far? Is that okay? All right. So now I'm going to do the next piece, right? And that's going to be the limit as x approaches 1 from the right. And no, I'll just move it over. It's x minus 2b quantity squared. So if I FOIL that out, I'm going to have x squared minus 4 xb, is that right? plus 4b squared. Does that seem right to you guys?
That's what I got.
Yeah, I think that's right. And again, I can't simplify or combine like terms, so I'm going to take the limit, meaning I'm going to plug the 1 in for x. So I'm going to have 1 minus 4b plus 4b squared. So let me rewrite that. 4b squared minus 4b plus 1, right? And now we're going to set these two things equal to each other and solve. So I'm going to make my pen thinner. We've got b squared plus 2b plus 1 is equal to 4b squared minus 4b plus 1. And right away, the ones are going to cancel because they're the same sign, opposite sides of the equal sign, right? Remember that from algebra. And now I'm going to combine like terms. So I'm just going to move everything over to the left because I like things on the left and 0 on the right. It's just a personal preference, but it doesn't matter. So if I move the 4b squared over, I'm going to have negative 3b squared on the left. And if I add 4b to 2b plus 6b is equal to 0, right? And I'm going to factor out a negative 3b. So that's going to leave me with b minus 2 equals 0, right? I have to be careful of my signs. So what I have is I have negative 3b equals 0, and I have b minus 2 equals to 0. So I'm going to have two values of b that will actually make this function continuous. So it's going to be b equals to 0 and b equals to 2. All right? Did you not get those numbers?
I did get those numbers.
So then...
I just wanted to make sure I was.
Oh, okay, because the answer should be in Bob. Did Bob have a different answer or something? Let's see. What section is it? 2.8, right? 13? Yeah, B is 0 and 2. So you know I posted Bob in the modules. It's at the end, just so you know. You can check your answers there to see if you're on the right track.
Yeah, but I still need to watch my signs because
Mhm.
I didn't get the negative 3b.
Oh, all right. Yeah, be careful with the signs. Cool. Anything else? Anybody? All right, so now I'm going to ask this question. We've been through 8 sections in chapter 2. There's a lot, right? And the question that I have for you is this: is there any particular section that you feel maybe we went too fast, or you didn't quite feel comfortable with the material in that section, and you would like me to do it again, go over it again? Is there any part of chapter 2 that any of you want to see happen again? Yeah.
I think after we get going through the review, where we can actually work through some of the problems.
And then decide? Okay, so what I'm going to do right now is I'm going to publish the review. There's a Word doc and a PDF version, and what I want you to know is that the answer key is on the very last page of each one, so you can kind of gauge yourself to see if you're on the right track. And I want you for the rest of the class to work on those, all right? And if you have any questions, I'll be right here to help you. However, we're going to go over any questions you have, or all of them, next time I see you. So that was today, Tuesday, so Thursday, right? Hopefully you're all here. Yeah.
For the test, are you doing it the same way AP would be graded? So you expect the same format of like how we write it all out?
Yeah,
Alright,
I don't deviate from that. And the reason is because I need to train you guys to get used to working in that form. Okay, so you're going to be under the pressure of a test, and you're going to want to do good, of course, I hope. I can't imagine any kid saying, hey, I want to do bad on this test. So, you know, yeah, that'll be sharp or keen in the front of your mind, trust me. So yeah, you're going to have to write it out. I think for this test, or usually in AB for the first semester, I'll tell you this, that, you know, on your, I wish I could just do away with the damn bells. On the real AP exam, it's almost a 4-hour test, and you have 2 parts that are multiple choice, 1 calculator, 1 non-calculator, and 2 parts that are free response, 1 calculator, 1 non-calculator. But in semester 1, you have to take a semester one review or test, right? In winter exams. So your tests, which are a joke compared to AP, are all multiple choice. So generally with the AB students, what I do is I give you all multiple choice tests for the first semester to prep you, to get you used to working in multiple choice mode for your exam in the, your semester exam. And then we start doing lots and lots more FRQs starting in January all the way up until the exam. So then you're really well versed in both types. So your test will probably be multiple choice next week. Okay. That doesn't make it any easier. All right, so let me go into Canvas, if that's possible.
How many questions kind of are we looking at?
We're looking at probably about 1,000 to 1,200 questions. And you'll have, you don't get the whole block, you'll probably get maybe 33 minutes to complete them. Do you believe me?
Yes, Miss Wilson, 100%.
Yeah, so I'm not sure. I never know until I make the test. However, if I'm planning to have a test with you all on Monday, that's an early release day, so I have to make sure I don't overtime it or undertime it. So I don't know at this point. What is our block? Down by 10 minutes or something like that, or 12 minutes than usual? I'm not sure. So I'll compare that, but I don't know how many questions. And it also depends on the nature of the questions. So some question or one question might be like super hard and we would expect it might take you 6 minutes to answer the question. Whereas another question, we would expect that you would answer it in like 2 seconds or something. So that's how, when we make tests like this, that's how we work them out, is by time. And so depending on the number of difficult questions, you may have like 3 problems because that might take up all the time. But if you have a bunch of easy problems, then, you might have 20 questions because you can do them all in, a minute or less. So it's based off of time and I never know until I look at the question. So really hard to say. Just know this, you're going to have a test and you should be able to complete it with 90% or higher accuracy within the time allotted. That's how your AP exam is going to be. You're going to have 3 hours and 3 3/4 hours to complete 4 sections, and you should have enough time to finish. A lot of students don't, and you can actually tell when you look at their work where they ran out of time. It's very easy to see where a kid runs out of time. So anyway, all right, let me open this up and stop talking. Ask me no questions for about 1 minute. Assignments. Gosh darn it. Bear with me a sec, guys. Chapter 1. And what I'm going to do is I'm going to open it up too. And I'm going to project it. Here it is. So let me copy it to, I got to copy it. So yesterday I copied a bunch of stuff over to your classes from block 5 and it didn't copy. I don't know. Things aren't copying well in Canvas for some reason. All right, so if you go to assignments and hang on a second, look way up at the top. Not yet. Hang on, I'm bringing it there. Okay, so way up at the top under homework, you should see chapter 2 review, right? And in fact, I think I'm just going to open it here and share this screen right from this computer instead of my, no, I'll do it from my iPad in case anybody has a question. But you'll see there's a Word doc and then there's a PDF version. So you can choose whatever one makes you the happiest. I'm going to open it now from my iPad if I can get into Canvas. We're going to see. Because, yeah, I keep getting errors going into Canvas. Canvas doesn't like to work well in the from the school internet at school. Like, in other words, I cannot grade at school. I try to open it and it will not open the assignments at school, but when I go home, it opens it. guess what? I don't grade at home. So you see I have 373 papers to grade. That's how behind I am. I've never usually that far behind, so I'm not happy. But anyway, chapter 2 review, click on the link, and I'm just going to upload this. You can disregard what I'm doing, but I'm going to upload this to my GoodNotes, and I'll just keep it open here in case you have a question. So I believe you went up to like number 13 or 14 when you did the partial review when I was absent, when I was in quarantine. So you don't have to redo them unless you want to. You can start at like where you left off, all right, and work from there. That's the newer material. Here we go.
Ms. Wilson, when is it going to be due?
It'll be due for Thursday.
Okay.
There aren't that many problems. Now, look, I opened the Word doc. You see what's happening? Can you guys see my screen that I'm sharing? You notice there's things missing. All right. And I don't know what the deal is, but the math is there. It's just not showing up here. So let me try the other one. Let me go into Canvas. You can see clearly in Canvas. No, actually it has stuff missing in there too. Let me try the PDF version and see. Remember, iPad doesn't like non-PDF things. So we'll see how this one turns out. So I know Mac users, you need a PDF. There it is. All right, so I need to open this one. Opening GoodNotes as a new document. Open. Import and open. There we go. Yeah. No, here we are. Yeah, so I think you guys did up to 13. Maybe you did 14. Yeah, you did 14, right? Oh, you didn't do 14? Oh, okay, then start with number 14 then. And again, if you have any questions, let me know. I'm going to shut my mic off on the computer. Chime in if you have any questions whatsoever. I am here to help you. Are you guys online doing okay? Any questions?
Yeah, I have a question.
Okay.
I was looking at 14 and I thought it's just with like annotation, almost like how to actually write it down on a piece of paper.
Oh, okay. All right.
Because when I looked at the answer, it was all really wonky and it was completely off from what I put.
What's his answer? Let's just say. So in 14, he says, well, looks like he's making a note. Okay, so like, yeah, so are you saying that the wonkiness is like this part right here? What are you saying? Is that what's bothering you? You said 14, right?
Yeah.
So he's just making a side note to let you know.
It wasn't the note, it was
Oh, it was the
action.
answer, B, F, and G?
Yeah.
Okay.
Yeah.
If we go to A, part A, let's see here. It says, list all the labeled points at which the derivative is positive, right? And we know that the derivative is going to be positive when the graph of f is increasing, right? So the graph is increasing here from A to C, but not including C, because at point C, it's switching between positive and negative. Do you agree? Or I'm sorry, increase and decrease. So from about, so I would say A and B is included on a increase. And let's see, is this E, F, and G? So his answer was like BAC or something, wasn't it? What was his answer, please?
It was BFG, Big Friendly Giant.
Big Friendly Giant. Okay, BFG. Okay, so this is what he means then, because even I was confused. I would have put in, you know, A and B for this first interval, or I would say the interval from A to C and the interval from E to H, something like that. But George had a different idea. And so what he's doing is he's choosing a point within the interval. So at point B, that's on an increasing function, and both points F and G are on the other interval of increase. It's just, it's not an AP thing. It's a publisher of the textbook weirdness thing. Okay.
Wait, so how would AP phrase it instead? Would they just be like A to C and like E to H or something like that?
AP would be a little more specific and say, you know, for which, so George says list all labeled points at which the derivative is positive. And AP would probably, yeah, they'd probably do it in an interval or something. I'm going to look right now. I have a multiple choice collection here and see if I can find something similar. I don't think it would be this. Let me say this, AP is actually very good at being really careful how they write a question. So I think you'll have an easier time. I'm going to look in the multiple choice and see what I can find here real quick. Let's see. Oh, not that. My computer's not it's going offline too. No, I'm looking. Go ahead. What question? Yeah.
Same things. I was curious about some of the FCA
A and K?
Yes.
Right, because they're endpoints.
Those are.
Mm-hmm.
Okay.
Mm-hmm.
So those are points because of the little.
Well, because, well, I mean, so this is where the graph starts, so it's an endpoint, a left endpoint, and this is where the graph ends, so that's the right endpoint. So the interval of this thing would be A through K, right? Kind of like this, right? Yeah. And derivatives don't exist at endpoints. I mean, a left or a right-hand derivative would, but the total derivative wouldn't.
Okay, because for my definition of critical point, I identified the zeros of the graph of the derivative. And so if we can't.
And where the derivative does not exist.
And with the derivative.
Right. Mm-hmm. See, the confusing part is most of the graphs and things that you deal with, you're dealing with where there's bumps and the derivative equals to 0, so you get that in your head. But you rarely see places where the derivative does not exist, but you have to keep endpoints in mind. They're special. This is really weird. You can talk, it's okay. Now, this is the most bizarre thing. I want to open with. Okay, so we're going to open with Adobe. Yeah, see, I'm scrolling through from 1969 all the way through 1997. And I don't see any graphs remotely close to being labeled that way and a question being posed that way. I really don't think you have to worry about it. It's a George Best thing. I mean, it's a good question, but it's confusing the way he's asking it. Mhm. And if I find one, I'll show it to you. Yep, not a single graph similar to it. Any other questions? Wait, I don't know if my microphone's on. Yeah, it's on. Any other questions from kids online, like on number 16? You gotten there? You doing okay with something like that? Hmm? Vivian, you doing okay? Vivian? Venkata, you doing okay?
Yes, I am.
Just checking.
Why did you cross off number 15?
Oh, because it's a pain to sketch that. And you're never going to have to do something like that. Now, if you want to do it, go for it. Just be aware that your graph's probably going to look a lot different than what George has in the back of the book there, or in the answer key. But it's, I mean, it's a good like mental, or it's a good exercise for your brain, but you don't have to do something like that ever in AP. So Anyway. You don't have to do it if you don't want to. If you want to, have fun with it. Anybody past number 16 yet? Okay, good. You are good. Ooh, limits. The fun stuff. Mm-hmm. 16. Yeah. Uh-huh.
And so I just plug it into my calculator
Mm-hmm.
and graph it and use the table function. How would I represent that on the APA thing?
You wouldn't. So they wouldn't expect for calculator use. If you use your calculator right, then you'll have the correct answer. So you don't have to do anything but use your calculator and write down the answer. Mm-hmm. Now, there are going to be times where you'd have to use your calculator and then justify something, so you'd have to jot a little something down. But you wouldn't have to state how you're using it or anything like that. We'll know if you get the answer correct. You'll see, you'll be experts by the time May comes around. Oh, there it is. The kids were trying to tell me yesterday. View options. Okay, guys, well, it's 1:11. The bell is going to ring. Wait a minute. Does our bell ring at 1:15 or 1:20? 1:15, right? Okay, so you can start wrapping it up because I can tell you, I have not been able to use the restroom since I got into school this morning because it's been meeting and class and proctoring in class. I have not had time to even pee, so I gotta run to the bathroom. So when the bell rings, I want you to go. So I can head to the bathroom, ready to pee my pants.
Can I ask you a question?
Yeah.
So,
Sorry, yeah.
17. So the limit of the equation, do we just plug those into our calculators and then?
Right. So, you could try plugging the value in. So like on A, let's say, if you plug a 0 in, you're going to get 0 on the top and you're going to get 0 on the bottom, and that's bad, right? So what you do is, you go ahead and put the function into y equals, you graph it, and I don't know what your graph's going to look like for that, but you come in from the left and from the right, or use your table to see what value the function's approaching. Make sense? You okay with that?
Yeah.
Okay.
What's the equation below A?
This one, the sine of 2x, so the limit should be 2/3, I bet.
Oh,
So
is it just another question?
This?
Yeah.
Oh yeah, I guess it's part D or something. Yeah, I'm sorry, I didn't realize that. Yeah, this is a D and it's not on there. Or a C. Oh yeah, it's to the right over here. You see that?
Yeah.
Okay, that's what happened. I see what you mean now. All right, you guys online, you can wrap it up. The bell is just about to ring. So I hope you have a fabulous rest of your day, and we'll see you on Thursday.
Goodbye.
This is supposed to be complete when we come back, right?
Yeah, Thursday.
Okay.
There aren't that many more questions to it, so you shouldn't have any trouble. Well, hopefully. If you do, it's okay too. We're going to talk about it on Thursday. I'm going to end my sharing on my iPad so I can charge it. Let's leave. Let's leave this meeting. Leave. And put it on the charger. My Apple Pencil on the charger.